Hi everybody. Today it is my great pleasure to give you an introduction on how to develop custom tools for NVIDIA Omniverse. In this session, we will see how you can build extensions and applications for the NVIDIA Omniverse platform. Before we go into the detail for Omniverse Kit, it is useful to get a full picture of the platform. From left to right, we have the Nucleus platform. This is the collaboration engine that enables you to store USD files and collaborate on them in real time. Connect is the divisions that looked after all of the portals that connect applications that you already know and use into the Omniverse world. I'll go back to Kit in a second. The simulation group is doing physics and digital humans and procedural animations, fluid dynamics, and many more. And of course, the RTX renderer, which is an incredibly scalable, full photoreal path tracing renderer that will scale to many GPUs and many nodes, providing you incredible feedback on your world. Kit in the center is the purpose of this discussion today, is a platform to develop app and extension for the Omniverse platform. We'll go into a lot of details about how you can leverage that to build incredible things. The overall platform itself is built upon a lot of the great technology that NVIDIA has to offer. At the very low level, of course, all of our GPUs, DPUs, and CPU, leveraging all of this functionality very deeply. Then a large software stacks, built over the many years of innovations and development into graphics, compute, and AI. Libraries that are used across the industry to power the best applications. Omniverse is built on those foundations. We've discussed about those 5 pillars: Connect, Nucleus, Kit, Simulations, and Renderer. Above that are the extensions. They are the mechanism on which you can extend the Omniverse platform with your own innovations and your own code. Out of these many extensions that maybe you have built and the one that we provide are created the Omniverse apps. Great example are the one that we have in the launcher today: Audio to Face or Create, Kaolin, Machinima doing animations, View for viewing, but also some of the one that we're building internally for driving simulations or robotics. Actually, this one is shared publicly. This entire platform is designed to be cloud native, designed for running on data centers. It is multi-GPU enabled at the lowest level. It uses standards like USD or MDL that are enabling your content to be completely free and open. It is obviously scalable and will run on all of the breadth of the RTX solutions that we have in the RTX family. Today, the focus, though, is really on the Omniverse side. How, leveraging the NVIDIA technology, we're building Omniverse and a platform for you to build incredible things there. There is already great introduction video that you might want to look for that we've shipped in January and in December when we opened around microservices, how to build great and intuitive UIs, and also just overview of the platform that you might have not seen. But let's get into it and then discuss more of the detail for today. Here are the topics that I want to cover. The Kit extension system. It is fundamental to you being able to leverage the Omniverse platform in a very custom way. Our UI system, Omniverse UI, some core extension and API that you might want to learn and use to build your applications, concept around microservices, and few sneak peeks on things that are coming in the summer that you are, I'm sure, going to like very much. If we look at an app, Omniverse Create, for example, it is easy to think that it is built like a traditional applications where you have all of these things as a monolithic pieces that you can use and modify. The reality, though, is different. Create itself is built out of Kit extensions that are entirely modular, interchangeable, that you can remove or add, where you can bring your own. Every single piece of Create or View or other apps are extensions, small pieces of code that are tailored to do one thing and one thing really well, and then contribute to the overall systems. So what are Kit extensions? They are the building block of any Kit applications. In the system, almost everything is an extension. They are named in versions and packaged to be loaded at runtimes. They can depend on each other, enabling you to have complex tree of dependency and be able to be auto-reloaded at runtimes, enabling you great fluid development practices. Here is the extension manager. With this tool, you're able to browse all of the extensions in your system, have some more information about them, enable them or not, and then look at different properties that they have. So what is the simplest extension you can create? It is simply a configuration file, this extension.toml. It defines content of your extensions and also its general properties, its title, its versions, its dependency, as we discussed, and can have Python code or binary C++ code as well. As we said, the dependency enables you to include in your extensions other extensions and their behaviors, enabling you to leverage either our contributions or build extension graphs that are enabling you to build complex applications out of small modules. In the extension manager, you can see this graph dependency and then also have access to the extension folder that will contain its code. Remember, most of these extensions are written in Python, and so the source code comes available with the platform, enabling you to inspect and learn directly from these production-grade extensions that are coming with the system. At the application level, it is very similar. An application is simply some sort of extensions. It depends on a set of extensions on which it relies for its features and then provide that dependency. To run it, you can simply do kit.exe myapp.kit. This is all it takes to launch an application in Omniverse. The Python extensions that are very simple have this manifest that we just discussed and a simple Python entry point that will be enabled or started when the extension gets activated and then deactivated when it runs out. By simply running that code, you're able to start going and building very powerful extensions. This is really just a quick introduction to the system. But if you look in Kit, there are over 200 extensions that you can look for and learn from. Remember, most of them are written in Python, and so the source code comes directly available inside the SDK. You can try changing them, any of them at runtime, by changing some of these properties. When you save, it dynamically reloads the extensions, enabling you to see the effect instantly. There's a script editor inside the applications that enable you to do some interactive testing. This nice, interesting graph in the center is actually the dependency graph for Create version. The little dot on the right is the create.kit file that we discussed about. It depends on about 30 to 40 extensions at the highest level. Things like the viewport, the script editor, some USD libraries. Them in turn rely on other ones, building this graph of about 100 extensions that are comprising what you see when you launch Create. Let's talk a little bit about Omniverse UI. When we start designing the user interface for Omniverse, we think about this key important feature for our platform. We wanted something that was modern, fast, and lightweight. It had to become the foundation of any Omniverse applications. We got inspired by Swift UI or React to build a very declarative and dynamic syntax. It had to be fully stylable so the applications could take on many different looks seamlessly. We leverage something similar to the CSS style sheets from HTML. We need to have a broad support of platform. The core is written in C++ for performance, but most of the user interactions is done via Python, where it's the first-class support language for the UI system. We run on Linux and Windows equally well, leveraging DirectX 12 or Vulkan graphic API. We're also working on support for other platforms, ARM of course, and Mac in the future. Here is a great application that is built using Omniverse UI, the Omniverse UI Documentations. Everything that you see here is written in Omniverse UI and Python using Kit. We looked at the documentations that was written in HTML for the platform in general and match its style and look and feel by simply using CSS style sheets. The great feature of these applications is it's completely interactive. It is actually running the UI system. Button clicks, slider slides, and different list drag and drops are interactive in the applications. It is also a tremendous sample for you to look at because it's entirely written in Python, and so the source becomes available inside the extension. We discussed a little bit about the dynamic syntax. Here is a great example of a few lines of code that build this UI on the right-hand side. See how, using Python specific syntax language, we are able to build something very concise but very expressive to build a vertical stacks, a series of elements. A Z stack is elements stacked on top of each other like layers. We're building a UI image with a single line. This placer enables us to place text anywhere into the viewport where we're creating a simple label. See how we can start using the style to change the font size of that element very dynamically. Later, we build separators and buttons. Here again, see how the buttons can be added with simple styling to make it green and with white text. You also see that we can dynamically use closures or lambda functions to add callback into the system. All in all, very simple code to read, very expressive, building UI rapidly. And while building these samples, I was able to leverage the interactive reloading features where I would simply type some more ideas, increase the width of some things or the height of some things. And every time I would save in VS Code, my applications and my UI would instantly refresh and match the new directive that I was given inside the code. With Omniverse UI, we've included great extensions that enable you to do even more, including the graph framework. Graphs are notoriously difficult to build. Small graphs are easy, but complex and rich graph applications takes a lot of time. Leveraging Omni.UI, Kit, and the Python interface of the entire platform, we build a graph framework that is very customizable and easy to get started with. It is inspired by a model view controller pattern where you write the model. What is the graph meant to represent? You decide the model objects, and then you also are able to customize the look of each of the nodes very expressively using Omniverse UI. At the center, a graph delegates is able to coordinate this tooling together and do all of the hard work for you. These extensions are entirely written in Python, and so again, come with source available, and it's very easy to inspect and learn from. Here is the full API of the model, enabling you to write all of these very interesting connections between your informations and then the front end in a very simple way. Again, you can write any type of applications using this model. Here is a Kit application designed entirely in Python, leveraging some of the other Omni.UI components like Treeview, buttons, and different components. And in the center, this graph view. You see that the engineers was able to customize the look of the node to include widgets, sliders, and buttons inside the node directly, and represents what here is an application to convert from different type of material and different platforms. Again, all written in Python, very easy to do, and use the Omniverse UI to do that. In these sections, I wanted to cover a few interesting API that you might leverage to build your applications. We discussed about the breadth of the general component that you have in Omni.UI. One very powerful and very flexible is the Treeview. It is a Treeview, but it also has columns, so you can use it as a table view. And of course, with a single columns, you can build great efficient list view. Here are 4 extensions that are built entirely in Python that leverage the Treeview at great effect. In the content browser, we use it to browse the file system or the Omniverse file tree, leveraging showing files and folders. In the stage view, we traverse the USD stage and show the prims and their various types And here you can see the great effects that you can use with columns to be able to show visibility and types. The layer window leverages that as well to show the layer hierarchy inside USD files. And the extension manager that we've seen earlier, we make use of it for the list view. And here you can see that each of the row is using rich UI language to be able to define those items, include checkbox and different stylings. Again, all using Omni.UI and CSS styling. The web has become a really important platform for many different tools. And so it is important that you're able to combine web technology or web widgets directly inside your Omniverse apps. For that, we're bringing Chrome Embedded Framework as a widget inside Omni.UI. It's effectively having the power of Chrome directly into a widget available for your applications. You can implement bidirectional communications between the Python engine and the JavaScript engine, enabling you to communicate seamlessly between the two. This enables you to run anything that the web can do. So of course, you can play video here showing YouTube directly embedded into an applications. You can also leverage some of the video and audio conferencing solutions running inside web browsers. Here, WebRTC showing as a widget directly into an applications, enable you some interesting connectivity with the web. You can have the web running inside Kit. Well, now, what if you want to run Kit inside the web browsers? For that, we have great technology around web streaming. Here is Create, the applications that we ship in the launcher, running directly into the browser. Well, I should say it is running into the data center somewhere remotely, and it's streaming using our state-of-the-art technology of streamings that was developed originally for GeForce Now. And you can interact directly with your application remotely inside the browsers. All of those comes for developer structures where the sample codes provide great interface so you can connect these viewports at different places inside your applications, and you're able to customize it greatly. So of course, here is the 3D applications that you can run into the browsers. That's really useful. But remember these applications that we talked a little bit earlier that was built using Omni.UI and the Graph framework. With few modifications, just adding the streaming extensions and the configurations, we're able to then stream these applications from somewhere in the data center into a browser, meaning that you can now experience these applications inside a Mac or a Chromebook without problems, opening very interesting workflow for your applications and your development. Microservices are key in building distributed and collaborative apps in the data center world. For that, you have two approaches in Omniverse. First, you can use Nucleus. Nucleus, by nature, is a microservices environment. It enables you to have a shared database of entities and items and leveraging USD to store these. And the Nucleus sync engine is able to communicate with all of the different connectors, the change happening to the 3D worlds. And so you're able to do microservices behavior between Unreal, Maya, maybe Photoshops, including any Omniverse Kit apps that you might have. That's very much one way to do distributed compute, leveraging the Nucleus server as a collaboration engine. The other ways is because Kit is built upon Python and open source technologies, we're able to bubble up all of the great APIs that are available in the web to write microservices using Python. That includes technology around Docker, Kubernetes, and OpenAPI. We've simplified the access to this technology by building extensions inside Kit that makes it really easy for you to expose any code that you have as a microservices entry point and be able to talk to a remote Kit leveraging this. On the right-hand side, you see that from any applications, not necessarily using our API, you're able to do traditional HTTP requests to be able to interact with those Kit microservices running anywhere in your data center. Leveraging this technology, the team internally was able to render a large amount of contents because, of course, you can run Kit microservices with everything that Kit can offer. That means physics simulations, that means RTX rendering, that means AI, opening up to a world of possibility for synthetic data generations. Let's finish the talk with a couple of sneak preview at what's coming in the summer. We've developed this new technology around searching and AI that enable you to have the breadth of actions possible inside Kit at your fingertip. I'm going to show a small video and describe what's happening. Here, the user type pressing tabs, search for dome light. It's created the dome light. Clear sky. Now the clear sky will appear. Okay, maybe I want something a bit more cloudy. Cloud. The cloud appears. Okay, so let's put some trees in there. Searching for trees. Okay, let me see. Oh, this one looks great. So it's dragging onto the grass, interactively bringing that USD from the Nucleus server into the world. Okay, that looks great. Maybe we'll add some bushes to see which one it is. Okay, now this one, red one, looks great. Able to drag it and drop it. Again, remember, this entire scene is fully path tracing while I'm doing that. Now, I'm selecting the ground. Now, because I'm selecting the ground, the system knows that I might want to do something specific with it. I'm searching for some material. This one looks great. By selecting it, the material gets bounded to this geometry at the floor. Okay, let's add a bit more props. Maybe I'm looking for people to make that scene a bit more interesting. Again, I'm searching through the Nucleus database at really fast rates and able to find assets. Look at this search query, large red fall tree. Using AI and very interesting search technology, I'm able to find this red tree that will fit perfectly there on the right-hand side. Now, finish that composition by just adding something around this garage, grabbing a final piece of UI and dropping it there. Maybe changing a little bit the scales. Look, we've created these different adjustments and UI changes, all while path tracing these scenes at real times and without any UI by simply the power of AI and quick search. Very interesting technology coming to Omniverse this summer. Another one that I wanted to share with you is around our new UI system and something called Inspector. I will run this video and detail to you what's happening. On the right-hand side, you see a demo UI that was built using Omniverse UI. You see that we can inspect all of the UI elements that are in that composition here on the left dynamically by just looking at the UI and inspecting it. Now, our UI is here, render in the middle, where we see all of the different elements and their wireframes. We can look at our scene like if it was a 3D scene in wireframe. We can even rotate it and look at the 3D layering effect of all of our pieces to be able to understand them properly. Because those are all running dynamically inside Kit, we can change any of the property of our UI element and then affect any of these properties. So here I'm going to select the label that is at the top and I'm going to change its property. You see, text is cool. No, let's remove that, inspector. And so you see how we can directly affect property in that UI by changing their graph representations. Again, a couple of different modifications here just to show increasing the height of that particular lines and then readjusting it. Here, changing the slider, what's the minimum and maximum value? You can see that the sliders is updating in real time. Finally, we're going to go to the style property. We discussed that everything in Omni.UI is driven by style. Here we see all of the style property that are coming along with these different widgets. This is fully interactive. I'm able to update the style of any of these components and in real time see the effect that it has on my composition, be able to really very intuitively choose the right color or the right design for my applications. There is a lot more to come in those videos in the future, but a lot of really cool stuff happening in the world of UI. We're going to conclude that talk to give you 3 fundamental things that you have to take away from Omniverse Kit. At the core, Omniverse Kit is a flexible and extensible extension system that you can leverage to build great simulations and world-building applications. It comes with sets of powerful and broad extensions that we've built and used in production to create our apps that are all available for you to start from or compose into your own creations. And finally, it is giving you access to all of the great API that are available from NVIDIA and great SDKs, things around physics simulations, of course, all of USD, the MDL physically plausible materials, audio to face, simulations of fluids and rigid body dynamics, all of the work around AI pose estimations, many more that are coming, and every time we add some more to the platform. We're excited to see what you will be using Omniverse Kit for and Omniverse in general. You can download it today. It's available from the NVIDIA website through the launcher. Download it, install it, and then let us know what you think. There is great forum for you to interact with us every day.